Hi, guys. You made it this far. Congratulations. Just go ahead and finish strong. You got this, okay? And you got this because we have handled many examples right now that deal with fractions. So let me rewrite this one more time, okay? Let me just go ahead and, oh, that was silly. Let's see, that's just a 10, right? So it's just a 10. Now let me write it like so. Okay, like so. Excuse me. 10 over 1. What has been the technique? At least common multiple, okay? Over 1, over 1. I guess I could have saved myself some work, okay? But hopefully you recognize that this is probably one of the easiest least common multiple that we have seen throughout this review. Every denominator needs to have an x. This one already has it. Times x, times x, times x, times x. What does that look like now? No more denominators. Okay, let me write it like so. 10x minus 12 is equal to, ooh, be careful here, x squared plus 18x. Ooh, quadratic equation skills engage because I recognize the x squared quantity. All right, what does that mean? Standard form. Let's see what comes out of standard form, okay? And then we'll make some decisions based out of that. So I need it to be equal to 0. So I am going to move this to the right side. I'm also going to move this to the right side because it doesn't matter where the equal to 0 is located as long as it's equal to 0. Okay, so this is perfectly okay. But if you don't like it, that's perfectly okay. Put that on the other side. Simple. Let's make it simple. The number in front of x squared is 1. So 1 times 12 is 12. 1 and 12, 2 and 6, 3 and 4. What will be the right combination of numbers that will get us that 8? You're right. 2 and 6. Come on, highlighter. A equals 1. Let me highlight that too. That's so good. I like it because we can easily write x plus 2, x plus 6 equal to 0. What does that mean? X plus 2 is equal to 0, or x plus 6 is equal to 0. Moving quickly through this, x is equal to negative 2. X must be equal to negative 6. Do we need to be careful as far as like, are these numbers going to make any denominators equal to 0? And the answer is no. So we are going to take both of these answers. Alrighty then. That's a good start. I like it. And now, ooh, we're going to solve some inequalities. Okay, I'll give you some tips and hints as what to do as we go through some of these examples. All right. So, negative 4 times v plus 19 less than or equal to negative 1. Just like if we were solving an equation, let's isolate the variable. Negative 4 times v is less than or equal to 18. Divide by negative 4. But this is where it gets tricky. When it comes to inequalities and we divide, we divide by a negative, we must flip the direction of the inequality symbol. So we get negative 18 over 4, or better yet, negative 9, or I can write this better. This will be v is greater than or equal to negative 9 over 2. The graph looks something like this. This will be 5 here. This will be 4. This will be 9 over 2. So the graph will have a solid circle, and we're going to choose everything. And we're going to choose everything to the right of 4.5, right? 4.5. Okay, everything to the right. Why? Because all these numbers to the right of it will be greater than. So tip, tip. When working with inequalities, it is best to have the variable on the left. It just makes it a lot simpler to understand what the inequality is telling us. Like in this, it is telling us that all the answers will be greater than negative. Oh, I made a mistake. Wait, I made a mistake. I made a mistake. I made a mistake. I made a mistake. I didn't check the signs. -5, -4, negative. Okay, that's better. So all the answers will be to the right of -9/2. Okay. So therefore, again, if the variable is on the left, it is a lot easier to understand. Could it be on the right? Absolutely. Okay, absolutely. But I'm choosing to say or give you a tip that is easier when it is on the left. I think you're gonna have to graph it. I think you might also need to write this solution in interval notation. So I'm using a bracket, because it is a filled-in circle. Because it is a equal to inequality symbol, and eventually all the way to the right will be positive infinity. Let's just try some other examples and see what kind of jelly jam we get ourselves into. Okay. Oh, that was it for that. Okay. Let me talk a little more then. Let me talk a little more. Okay, let me talk a little more. If the answer would have been just greater than -9/2, then the interval notation would have been parentheses -1/2 positive infinity, but the graph would have had an open circle, but I'm still selecting answers to the right. Okay, I'm going to leave that alone, and I'm going to solve the next example, which is an absolute value equation. Tips. If I'm going to be able to do this number needs to be positive, but it could also be done if it is 0. Okay. It cannot be done, and let me use a red pencil now because I need to call your attention. If it's negative, if this number is negative, can't do it. Can't do it. Okay? Can do it. Okay? And hopefully we won't have any crazy situations, you know. I'm just letting you know that if we're going to solve an equation, I need a variable, my friend. If we're solving an equation that looks like that, and this number is negative, can't do it. No solution. No solution. Okay, so let's go ahead and take care of this one. So we have the absolute value of 6y plus 18 is equal to -6. What I'm looking for here is, this is nothing tricky here. This number is positive. Then go ahead. Go ahead. Go ahead and solve it. Okay, let's solve it. We need to solve two equations. One where this 6 is negative, and the other one where this 6 is just positive. Okay, again, once again, positive, go ahead, do it. You need to solve two equations. One of those when this is, so get rid of the absolute value things and solve it when this is negative. Get rid of the things and solve it when this is positive. -18, -18, 6y is equal to -24. Dividing by 6, y is equal to -4. Okay, -18, -18. 6y is equal to -12. Divide by 6, divide by 6, y is equal to -2. So we have two solutions. One of those is -4. The other one is -2. Alrighty then. Moving on. Oh, okay. I think we kind of talked about something like this on whatever that example it was on the last clip. If we need to solve this equation, we need to get rid of this radical, this square root of business here. But in order to do that, we need to understand what is the operation that is the opposite of taking the square root. And if you're thinking squaring, you're thinking correctly. Square roots and squaring cancel each other out. So we get 2x minus 8 is equal to 16. And after that, it's a walk in the park because we have done a lot of linear equations that this is becoming a little bit too easy now, which is, of course, sometimes we just kind of need a break, right? Something simple and to the point. Beautiful. That is excellent. Let's move on. Oh, look at this inequality. It's got a little bit more to it, doesn't it? What is this little more to it? Well, it's got some distribution going on. It's got variables on both sides. So let's go ahead and see what this is all about. Let's do the distribution. Negative 7u minus 35 plus 25 less than 18 minus 3u. If you've been listening to me, you will remember that I recommend that variables be on the left side. So I am adding 3u. Numbers be on the right side. So let's add 10. That cancels that. That cancels that. We get, negative 4. U is less than 28. Divide by negative 4. And if you've been listening to me, when we divide by a negative, or also multiply, we flip the inequality symbol. So in this case, we get negative 7. So let's see, I'm just going to add to this. The graph will look like this. This is negative 7, open circle in this direction. And the interval notation will be parentheses, negative 7, positive infinity, okay? All right. Okay, let's just leave that alone and see what other jelly jams we could get ourselves into. Oh, this is a compound inequality. So let me take a few minutes to go ahead and talk about this example, okay? The word "and" means intersection. Why do I say that? Here we have an inequality, and here we have another inequality. This inequality is going to have its own graph. This inequality is going to have also its own graph. But what we are looking for is the "and," the intersection of the solution sets. So why don't we just get down to business, okay? Let me use two different colors. Let me use this blue for 2x minus 6 is greater than or equal to negative 8. So let me go ahead and do this now before I change ink. So plus 6, 2x is greater than or equal to negative 2. Divide by 2. X is greater than or equal to negative 1. What does that look like? It's going to be a filled-in circle with everything towards the right. Okay, keep it steady. Okay. Let me choose now a different color. Let's use this green to solve 2x plus 3 is less than or equal to 7. So let's go through the motions. Again, minus 3, divided by 2. X is less than or equal to 2. What does that look like? Build-in circle. Everything to the right. So my question is, let me use a highlighter instead. Where do we find an intersection of these solution sets? You're right. That intersection is happening. Whoa, easy there, buddy. Whoa. From there to there. From there to there. So, the solution to this problem is from -1 to 2. So what do you need to show on X? Not all of this, only this. Filled in circle, and only this. And as you've done your homework and you practice with Alex, you see that there's some kind of clipping going on here. And so just make sure you do that, okay? But I want to take about a minute or so to talk about what would have happened if this would have said the word. Maybe it's the next example. Yes. Let's go on and move. Let's do the next example. Because this says the word or. The word or means union. Okay. What are we doing here? We're putting together. We're putting together the solution set of this inequality together with the solution set of that inequality. The idea is that we get something bigger. Let's work this out. Let's work this out. Okay. And so let's see, back to two different colors. Let's see what this jelly jam is all about. 3v minus 5 is greater than 1. Adding 5. 3v is greater than 6. Dividing by 3. V is greater than 2. I'm going to leave that alone for now. Let's see if there's a graph attached to this. No, there is not. Oh, okay. So let me do that. I'll do this in a second. Do a different color, the good old green here, and we have 2v plus 2 is less than 12. Running through the motions. -2 minus 2. Divide by 2. V is less than 5. And so let's see what this is all about. Okay, let's look at the number line. Here's 2. Here's 5. Here's one solution set. Here's the other solution set. You know, what are we doing, ladies and gents? We're putting them together. And putting them together means that we're doing all of this, all of that. That means that no matter how you look at this, we're going to pick every single thing here, and we're choosing all the numbers on the number line. Okay. We're choosing all the numbers greater than 2, the numbers less than 5. If we do that, we're going to choose all the numbers, and the answer is all real numbers for this example. Okay. Because with the word or, we're putting them together. And in this example, putting them together meant that you're just going to take every number that you could possibly think of. Okay? Alrighty then. As far as the graph is concerned, to make it a little cleaner, your graph is going to look like this. Okay? Your graph is going to look like that. Because this covers all of that. This one covers all of those. Everything has been covered in this example. I think I'm going to leave that alone for now, and I'm going to work out the very last example and call this quits, and in the hopes that this review actually did help you out. At least get going, get the brain going, get the pencil going, okay? Something about getting the pencil going is important. So let me give you some tips about solving this type of example. So if you have the absolute value of x is less than a number, positive, This number is positive. Then basically we're solving this inequality. Okay. Okay, that's what it comes down to. Okay. Now let's put this in practice. We're solving the absolute value inequality where this expression is less than 15. This number is positive. This can be done. Okay, now do it. Okay, I got you. Negative 15 less than this. Okay, that expression less than the positive number. To solve this inequality, we work from the inside out. Again, our goal is to isolate the variable, so we get negative 10 less than this goes away. Negative 5u, and this becomes 20. Divide by negative 5. We are dividing by, let me say it again, dividing by negative 5. Oh, I remember we flipped the inequality symbols, and this will be negative 4. So this looks funky. This looks really funky. Let me rewrite it for you. Negative 4 less than u less than 2. Because isn't negative 4 on the left of 2? Right? So the solutions to these examples will be open circles at negative 2, at negative 4, and at 2. And we're taking everything between these two numbers. In interval notation, that is negative 4, comma 2. The answers will be everything that is in between those two numbers. Okay. And for funs and giggles, let me just add, this is how you do this example. But what happens if that would have been negative 5 minus 5u greater than 15? What do we do instead? Instead, we solve these two inequalities. Less than negative 15, and we, negative 5 minus 5u greater than 15. That's what you would have done if that would have been a greater than, okay? So that is the last example. I hope this helped you out. Let's go get an A on that exam. Don't forget to submit your work, okay? And I'll see you guys for the next exam review. Bye-bye.